Hello everybody, in this example we're going to look at topic 3, lesson 1 of the enVision's math book, Algebra 2, and we're looking at example 5, interpret the polynomial interpret a polynomial model. So in science class, Abby mixes a fixed amount of baking soda with different amounts of vinegar in a bottle capped by a balloon. She records the amount of time it takes the gases produced by the reaction to inflate the balloon. From her data, Abby created a function to model the situation for x quarter cups of vinegar it takes. T of x equals negative 0.12x cubed plus x squared minus 3.38x plus 13.16 seconds to inflate the balloon. A. How long would it take to inflate the balloon 5 quarter cups of vinegar? Okay, so we'll go here. I'm going to rewrite my equation as T of 5, because again, remember x is quarter cups of vinegar, and I'm seeing how long it takes for 5 quarter cups of vinegar to inflate that balloon. All right, so T of 5 equals negative 0.12. Anywhere there's an x, I'm going to replace with the 5. So that's 5 cubed plus 5 squared minus 3.38 times 5. What I'm going to do is grab this whole function and move it over, because I did not leave myself enough room to write the whole equation out, plus 13.16. All right, so I'm going to use my handy dandy calculator to find this value, and what I found is T of 5 is going to be equal to 6.26. And this is 6.26 seconds. So again, this starts with a word problem. This starts with a lot of definitions, things like that. So I want to end it. So it would take, with a sentence, it would take approximately 6.26 seconds for the balloon to inflate with 5 quarter cups of vinegar. All right, so let's go back to the book and see what the book has to say. So the book did it a little bit differently. They graphed it, and what they did is they found when x is equal to 5, and they found that the value was approximately 6.3. This means that if Abby uses 5 cups of vinegar, the balloon will inflate in approximately 6.3 seconds. Another thing to think about as you look at this graphing device or this graphing technology is, what is 13.16 really represent when it's at time 0? Can we actually count, or not time 0, when it's at 0 quarter cups of vinegar versus this being 0 seconds? Can we actually include those values? Things to think about when looking at these types of problems. So recall that when you're using a graph in a real-world context, you need to consider the context, which, when thinking about the domain and range. Does it make sense for x to be negative? Does it make sense for y to be negative? Does it make sense for x and y to actually be 0? All right, so let's look at part B. What does the x and y intercepts of the graph mean in this context? Do those values make sense? So we just talked about that. So the x-intercepts is approximately 6.6, which means that if 6.6 cups of vinegar are used, the balloon would inflate in 0 seconds. That means it will inflate instantaneously. And can that actually happen? The y-intercepts is approximately 13.2, which means that if there is no vinegar, or if no vinegar is used, the balloon will inflate in 13.2 seconds. Again, if you're not having a chemical reaction between the baking soda and vinegar, does that actually make sense for us to include those values? So neither the x nor the y-intercepts make sense in this context. Therefore, we must limit the domain and range when considering this model. In other words, the domain, let me scroll this down, the domain would be 0, x, and 6.6. And notice how I'm not including these two values. The range would be from 0, y to 13.2. Again, not including those values because do those values really make sense in context of the problem? All right, so you try it. Danielle is engineering a new brand of shoes for X shoes sold. That was hard for me to say. In thousands, a profit of P of x equals negative 3x to the fourth plus 4x cubed minus 2x squared plus 5x plus $10 in 10,000s will be earned. How much will be earned? And what do the x and y intercepts of the graph mean to the context, and do we actually include them in the domain and range? All right, so I hope you guys have a fantastic day, and we will see you in the next video.